Okay, so just a counter question. So,
Right.
what would you do with the data in the ledger?
I don't know. That was not my job.
20, 30 years ago, when there was not a lot of awareness about testing, people would do sand testing with hand. They would pick up some green sand, throw it on the wall. In the last 10 years, the technology has.
You covered a little bit about where sand should be tested. What about the frequency? Tell us exactly what this is.
Okay, so black box is the holy grail of testing and control in foundry industry. This started somewhere close to 1990s and 2000s when entire generations and generations went into software engineering and IT.
If you're a Foundry professional, the chances are that your education really only began the moment you stepped foot into a Foundry and will never end, because experts say that Foundry is a lifelong learning process. And that's why we've created the Foundry School. So here's your once in a lifetime chance to be part of a global community that could be much bigger than ourselves. So join our 30-day trial and kickstart your Foundry career today. The link is going to be below in the description, and I'll see you on the inside. And if you make it to the inside, congratulations. So today we have with us Mr. Pushkraj on the show, right? One of the pioneers of sand testing equipments, to tell us whether we're a small foundry or a very large foundry with 10,000 tons, how to test our sand, right? And I think there's nobody else qualified to do this other than you. So let's just get straight into it.
Okay, first things first, there are many, many more people more qualified than me to talk about sand quality. But yes, about testing it, you can say that I have certain amount of knowledge associated with watching a lot of foundries do that.
Right. And from the script that I have here, you are really pushing the boundaries as to what's possible with sand testing. You know, you've really expanded and elaborated, and you're going to really big depths, especially with this black box, which I'm really curious about. Okay. So let's just, we have a lot to cover and some bonus questions at the end. So let's start with a small micro foundry, right? If I'm a garage foundry today and I don't have a lot of means to purchase sand testing equipment, what are some ways that you recommend testing sand?
So if you're a garage foundry and if you plan to do a really, really good casting, you probably shouldn't do it in garage in the first place.
Okay.
But then if you really want to test something, I think a good hobbyist can actually sense properties of sand with his own hands as well.
That's how I think they used to do it back in the day.
Yes, back in the day, like 20, 30 years ago, when there was not a lot of awareness about testing, people would do sand testing with hand. They would pick up some green sand, throw it on the wall. If it sticks, it works. If it doesn't stick, if it doesn't work. But the people who can actually sense this are probably gone.
Right.
And the newer generation probably doesn't know how to do it because they haven't spent a lot of time on the shop floor.
Right. So basically, to summarize, if you're a garage foundry and you want to test your sand, you only have to throw it at the wall and see if it sticks, and that's pretty much all you have to. A low cost approach.
Low cost approach.
So what about medium foundries?
So medium foundries. In this medium foundries also there are 3 tiers of foundries. So medium foundries encompass the smaller medium foundries, the medium foundries, and the larger medium.
Okay, so it's all different categories. So let's just categorize them first, so we understand what a smaller medium and a larger medium side foundry is actually.
Okay, so
in tonnage.
In tonnage. So typically, when foundries are about 150 tons maximum, that's where they generally migrate from one molding system to another molding system, which is typically a jolt squeeze system.
Right.
Then up to 500 tons, then you have this jolt squeeze system running in, or where in special cases where you need jolt squeeze system to be there, it can always go up to thousands of tons as well. But then these are the medium foundries.
Right.
And then the larger medium foundries have high pressure molding machines, probably a single line or a couple of lines doing about 1,500 tons. So these are the range of medium foundries.
Okay.
So going from smaller to larger, the testing requirements change drastically. So for the people who are doing hand molding and working up towards jolt squeeze molding, a moisture test, a mold hardness test, probably a scratch hardness test for cores, knowing how much bentonite there is in the sand. So clay testing, permeability of the sand, and the AFS analysis. These are the basic tests which the smaller foundries would run.
Right.
Going upwards towards the medium foundries, these tests, which can be manual in the first phase because of probably capital constraints or cost constraints of the equipment, can become digitized. And then the larger foundries, the larger medium foundries can actually adopt for online controls to start with, which will give them a lot of benefit in terms of knowing how they're making the castings, with what parameters they're working with, when they have digital equipment which is working online and observing the results. So that's where the medium range is
Okay.
covered.
So basically, you're trying to say that whether you're a medium foundry, you have to test your sand, right?
Yes.
But to the degree that your equipment changes, a more amount of automation in the sand testing process comes in, right? And that is how you go up the ranks with the machines.
That is correct, and actually also varies in terms of geography.
Okay.
If we are talking about countries like India, Vietnam, where the manpower is not very expensive, then you can definitely do away with having a couple of people doing this testing all the times, but then registering the readings, actually doing the test. Because many times it so happens that the equipment least count is 0.1 and the readings are taken and the moisture is 3.015. It's impossible.
Okay,
So,
you mean human error?
it's not human error. Many a times people don't even test.
Okay.
People would copy something from the previous day to the next day.
Right.
And then you really don't know why something is getting rejected because you don't have the readings.
Right. I was talking to your guy Dave before I came, and he showed me this equipment, this very neat-looking equipment that you have. I think we can show some photos of it,
Sure.
where it automates I think it has timestamps to the testing, right? And automatically goes to an app where everybody can see, okay, it was actually tested at these times, so nobody can actually skip and just make up those readings as they go.
True. So newer generation of equipment which is coming in. So in the last 10 years, the technology has actually become very accessible.
Right.
So even the handheld mold hardness testers that we have come up with can connect with the phone. So we have an app on the App Store by Versatile Equipment. And once you test the mold, it will give a reading on the phone, it will show it on the device. Then you can put notes that, okay, this was the part number, this was the mold number, and this is what the reading is. It's above the line or below the line. So you have the readings which you can correlate with the rejection later on. So digitizing the readings has become a very, very commonplace. Even right now, you also get some dongles which we give to our customers to digitize the readings of the equipment that they have bought in the past 10, 15 years.
Okay.
So that's a possibility now, which wasn't a possibility about 5, 10 years ago, or even a couple of years ago. Things like connecting an equipment to a Wi-Fi was a strange thing to ask for in a foundry premises. People wouldn't have internet, people wouldn't have a Wi-Fi. So, but now it's fairly simpler.
Right, right, and it gives us a glimpse as to how things have changed very quickly. Since you mentioned, like say a certain customer has machines that they bought in the past from another manufacturer. Let's just say, for example, do you also go in and retrofit them with IoT? Do you like IoT enable them as well, or is that something that you don't touch?
Well, we could if we can, but the equipment which we designed back in time, we're keeping in perspective what would happen in relative future. So the communication protocols which were implemented back then would and are still compatible with IoT devices. So most manufacturers didn't do that earlier on.
Correct.
So I'm not really sure about Simpson. They have some sort of a protocol which works with USB, but converting that USB into IoT it's a different ballgame. So
it's cheaper just for them to buy a new machine.
New machine.
You would say.
That makes sense.
Right,
That makes
right.
sense.
That's good. It's good to just get it out of the way. In case somebody says, "Oh, I have this machine. Can you like upgrade it to a version of 2.0 or something like that?" Yeah. So we've covered medium foundries. Now, when we go to large foundries, I think that is where your mysterious black box really starts to begin and take on a life of its own. So, how does changing? I mean, going from medium to large change the way that foundries would test a sand? Like, what exactly changes when they developed?
Okay, so First of all, let me be clear that there are not many large foundries in India. You can simply count them on your
Okay.
tip of your fingers.
Right.
So even in those foundries, first things first, capital in India is really expensive. So things that you would expect in a foundry in Europe or US, they wouldn't be in Indian large foundries by default.
Correct.
So a thing like a premixer, which is quite essential to control the sand before it goes to mixer, that concept simply doesn't exist in India. So storage of sand. Storage of sand is really important when it comes to getting right quality sand to the process. People don't have a lot of storage in many cases. That could have had resolved many problems that the foundries have today. But then the amount of capital investment involved, people do cut down on certain things which can be critical in future and which many times they don't think about earlier. So even in large foundries in India today, the kind of control systems which could have had been there in many cases don't exist. So, but when I go to foundries in, say, for example, Germany or in the US, they would have online control system on them by default, then checking at multiple places like temperature sensors, humidity sensors. These things would be there. So it's more dependent on geography and availability of capital to do things that matter here. So a cheap capital, which you can get at 1 or 2% in the Western countries, those times. Nowadays, it's slightly higher. Actually made them go for the right apparatus to begin with, which has not been the case in India so far.
Okay. And I would also assume that if it's a large foundry and they've already done this installation, it's very hard to go in and do modifications to the already existing sand plant to inbuild these processes, right? It would be really cumbersome.
Yes, it is very cumbersome, and sand being a bulk material, you need to, even if you have a new silo, you have to make sure that the sand reaches there. And then the whole logic behind consumption of sand on first in, first out basis and how you would manage that becomes a pain. It's very difficult to manage later on.
Right. So what is your answer then? If I'm stuck with machinery which is like 20 years old, because at that time that was what I could afford, like how do I upgrade my foundry?
How would you upgrade your foundry? I'm not an expert into this, but a lot of people do live with it, because scrapping the old plant and coming up with a new one might not be a very profitable affair than to live with the problems that are already there.
Correct.
Then the manpower suffers because of that. So
correct.
That's how things are.
So at each step of this journey, from small to medium to large, just describe some of the products that you have along the journey of a foundry person and as they upgrade. So like what would you recommend someone at a small level, medium level and higher level that Versatile actually provides?
So for smaller foundries, we have a set of equipment which would enable foundries to curtail rejection, like AFS analysis, hardness testers for molds and cores, strength testers, permeability testers. So there is a set of 7 or 8 basic parameters that the foundry needs to,
like a starter kit or some
kit.
Sort. Yeah.
So we have a starter kit, basic set.
Right.
Then there's an advanced set of digital and IoT connected equipment. And then there is the holy grail of things, which we call black box, and which is applicable in case of Greensand, no bake sand, and all different types of sand.
Okay, so it's basically it works on any type of sand.
Yes, it's a custom equipment based on the foundry's requirement of testing.
Okay.
It's a project in itself. And then we have a series which is called as VCAT series, Versatile Controller and Tester series, which does online control and testing for a Greensand foundry.
Correct.
So typically in India, people would like to control their sand at the mixer, and then you would use that.
Yeah, I think that's a whole different topic by itself. So since we're at it, let's just continue. So I think we were having a really good discussion as to where foundries should test their sand, right? And that's how VCAT came in as a topic, right? So I think VCAT essentially, you're saying you test the sand at the mold, right? At exactly what goes into the mold.
Okay. So 2 parts of this question.
Right.
Where should foundry actually test its sand?
Correct.
So there are different answers for different types of sand in this. So Most prevalent right now in India is the Greensand. So for Greensand, if you look at the entire flow from knockout to sieving, then cooling, storage, mixing, and then coming back to molding machine, this is the basic flow of sand, how it flows inside the system. Ideally, there is testing at every different point in the system. So post sieving, when the sand is going inside a cooler, the starting temperature is measured.
Okay.
If you have the facility to check moisture, it is measured. Then based on the volume of sand which is passing through, moisture is added. Then at the output, you check the moisture and the temperature. Then when it goes back, goes up into the silo, while it is going to the mixer, then you again check for moisture, because sand has been sitting, it has been cooling down. You check for moisture, you check for temperature. In the mixer, you would control the compactability, strength, based on moisture. Moisture is used as a variable here. And then in the outlet, you get a consistent sand. But then from mixer to molding machine, which probably sits 50 meters away, the sand properties change, because sand properties are more or less very close related to moisture. So moisture evaporates. And by the time it's at the molding machine, the properties change. So at the molding machine, you should have another checkpoint to check compactability, moisture, permeability, and strength. And then at the point of use, which is after the mold is made, before pouring, you can check it for hardness. So sand is checked at so many plethora of locations for the real control to have.
And this is only green sand.
This is only green sand.
Right.
For sands like no-bake sand, there are not a lot of systems that are currently being in use. It's a very robust system to begin with. But then for checking of no-bake sand, though we have testing apparatus in the laboratory, we also have the black box which caters to the requirement of testing in no-bake, which can be critical.
Okay, so you covered a little bit about where sand should be tested. Okay, and with green sand, it sounds like almost everywhere, right?
True.
Now, what about the frequency? Because when I started my first job in Belgaum at a foundry, my first job was a lab assistant with sand testing. So I used to use the permeability test.
Okay.
I used to use the compaction, compress it, and then check how much moisture was there, heat it up. It used to make that noise. That was literally my first job.
Okay.
Right. So I don't know a lot about sand testing, but I had to go there every hour. Every hour I had to go and draw a sample, and then I would come to the lab and then write down on a long ledger 10 years back. So no digitalization at all.
Okay, so just a counter question. So
right.
What would you do with the data in the ledger?
I don't know. That was not my job. That's a good question though. Because I think it was almost like whoever joined the foundry, they started as a lab assistant, right?
Okay.
And that person's job was only to go and get the bloody samples, right? So again, comes back to your point. Like there were a lot of times where I could have just copied from something on top and fudged the readings a little bit, which I did not actually. I'm very diligent in my work, but it's a really good question, because somebody else, arguably with a little more intelligence and experience, would have to go to that data and draw some inferences from it.
True.
So how does that work today?
So there are again two parts. So first we are talking about frequency, and the second is about how you would use the data.
Yeah.
And that's the side.
And that's lunchtime.
Yeah.
Yeah. All right.
Okay. So the frequency and use of data. So frequency is typically decided on the amount of problems you already have. A quality inspection system is only as good as the number of problems you have.
Okay.
If you don't have any problems, you don't need to check anything.
Okay, that's really powerful. I mean, I think you should repeat it. Frequency is dependent on the amount of problems that you have, rejections, right?
Yes.
Okay, right.
So in Indian context, the main problem is the consistency of raw materials that the foundry would get, and the design of process as well. In the Western world, they have great quality raw materials. So even with very little controls, they can do a really good job.
Correct.
So for India, if I've seen some of the best customers that we have who have really good quality practices, do testing very, very frequently, and they run with very few rejections.
Right.
So that's how things actually work in terms of frequency. So if we have a lot of problems, it is better to have a lot of readings to correlate it with those problems
Right.
and troubleshoot them later on. So, like say VCAP 2, which sits on the molding machine, checks sand for every mold.
Every mold.
Every mold.
Okay.
So, if you're running 100 molds per hour line, which is how many molds per minute? It's about 15 molds, maybe, no, 5 molds a minute.
Yeah.
It's about 12, 15 seconds a mold. So, you need to do the entire testing in those 10, 15 seconds. So, the number of readings that you get is phenomenal. So the analysis that you can do with this, even a Six Sigma analysis,
Right.
it's pretty much feasible to be done. And once that is done, once you have a solution how to control the sand, then you can actually reduce the checking frequency.
If you find that everything is going as per plan.
Everything is going as per plan, the right changes have been done. Sometimes even if you just increase your compactability set points by 2 points, your mold breakage would go down drastically by 50% or 60%. So unless you know that this certain compactability reading is running and it is probably causing this problem, and then you change it and you see the result, then you know what compactability set point is to be put. As long as that compactability set point is met,
Correct.
you're absolutely fine to go ahead with what you're doing.
This is just an off-topic question.
Yeah.
Like we know that Google Maps today works on a lot of data points, and that's why it's accurate, right? So I don't know if I actively have to consent to Google Maps whether I'm okay with sharing my data, my speed, because tomorrow it may be used by the transport authority to find me. It knows how fast I'm going, right? But today I know that it's used by Google to better serve me and build the app better. Like, do you have like a sort of model where you go to Foundries and say, okay, share your data with us. We won't say what you're doing, who your customer is, what you're making, but we'll use it to better our equipment, and then there would be a shared benefit over the industry. Is that something that you, I don't know if you're doing it right now, but is it something that you maybe think of doing in the future where someone can sign a form? We're okay with having just the figures. I mean, nothing more than that.
It's a really, really good question in the context that we have right now, because everything is getting IoTified. So the data is on the server. So some corporates have a very strange policy that, we want to have the data on our own server inside our premises. These people do lose out on the machine learning and AI capabilities, which will come along with the server deployment later on. They would be stuck with legacy systems, which would host the data in their own server, and probably nothing is doing anything about it. The point of testing in a foundry, the most important point is your readings have nothing to do with my
Somebody
process.
else's, right?
If I copy your readings, your set points into my system, I might get totally different results. So nobody can do anything with somebody else's result, even if the data gets stolen by chance, which is not even a possibility.
Right.
Nobody can do anything with your data. So I fail to understand the non-cooperation in terms of data sharing and having just share knowledge to grow knowledge, as Arjun says here, that if you don't share that knowledge, it's not going to grow. You yourself are not going to grow. But anyway, we have come a long way from where people were not sharing anything when investment casting was a new thing in 2002s and 3s. You wouldn't get a shred of information anywhere. And people would build huge walls around their factories so that nobody should be able to peep into their process.
Okay.
It was
that serious.
It was that serious.
Right.
So people would protect their intellectual property like there is no end to it. There's no tomorrow, kind of. But now things are so abundant. There is so much information everywhere. Even if you ask your casting defect on ChatGPT, it will give you 10 solutions which you can actually practically implement.
Yeah, right.
That being said, it's easy, right? It's good if you share your information with other people and get the solutions that would work for you. But still, that level of cooperation is yet to come into industry.
Right.
Though we are collecting data on the IoT cloud platform, we do not interact with it ourselves. We do not see what data is coming in. It's for the customer himself to check what is coming and make sense out of it. We can probably deploy an ML model onto it tomorrow for them themselves to
Yeah,
understand.
that could be like a very nice addition to a SaaS model, which you could build on with their own data, like a customized approach.
Customize. So
Right.
essentially, just like ChatGPT,
Right.
you interact with it.
Right.
Based on your interactions, it will give answer to your next question, just the same way.
Right.
The AI can see the data. You can put in, okay, I have this rejection in this particular batch. What do you suggest? It will probably tell you a few things to change.
Like you can build up like a AI model for them, just for their personalized
Yes.
with their personalized data for their Foundry.
Yes, like your personal chat agent for yourself
Right.
only.
Right. That's good. So since we were talking about VCAT, you also said that you test sand in every mold, right? That's where the actual VCAT tool is really good at. But we also went a little further, and I think you mentioned that the absolute groundbreaking test would be if you could segregate casting defects and then correlate them to the mold, so that you can draw like an inference and you could make like a change for future references, right? I think that was something that you're working on currently. So talk a little bit about that.
Okay, so the holy grail of testing and control in foundry industry is to identify each casting by a unique number, which also means from that unique number, you know the mold number as well. So based on that unique number, you can actually track it through melting. So you know which melt is going into which mold. You have the spectral results for it. Then when the casting is going ahead and going out after the shot blasting, you have probably an automated system which will check the casting for surface defects. Then it also reads the number on the casting. So now you know the sand parameters, you know the casting number, you know the melting parameters, you know what defects came into the casting. So becomes a closed loop.
Right.
That at the final stage, if there is a casting analysis system which segregates the casting itself, and you have the identification of the mold, this whole thing becomes a closed loop, and it's the natural progression of the industry where it should go, right? So that people can focus more into analysis, people can focus more onto material ups and downs, optimizing the castings. So these things can become more prevalent than spending time into doing this manual work of
Correct.
Analysis and testing and stuff like that.
So
that's
how far are we from that reality?
We are actually fairly close to it.
Like
reality.
The industry in whole or versatile?
In versatile, yes. So we have a new venture called as Sahas Labs. In Sahas Labs, we work with mathematical modeling of recognizing an object. So say, for example, something is coming in on a conveyor belt. Cameras would look at it, make a mathematical model, a 3D model of it, fit it with the 3D model which you already have in the database, okay, and check what deviation the part has with the model, see which defect it is. See, for example, if it is swelling, if it is cap, segregate the defects. If there is just extra material on the gates, grind it and put it forward in the OK jobs. And once you have this data, then it can be fed back. So we actually never imagined as versatile that we would be working in mathematics as a domain, and we would have people working on mathematical modeling, but here we are working on that. So that's that. And the second problem statement of this closed loop feedback is the identification of mold, each individual casting. So people are trying to solve it. We have one solution. We don't know whether it works or not, but we have one solution. We haven't tried it still on the shop floor.
Right.
But yes, both fronts we are working out. And then we have a third system, which you earlier mentioned, the black box.
Right.
So these three things together can be
Stuff of the future.
Elemental importance. Stuff of the future.
Yeah, I think I'm going to have to come back to dive into these. But I think I'll just describe to the audience what I saw. So I entered here in the morning and looking around for a place to film. So he showed me the conference room where we're sitting in right now. But I think opposite the conference room, there's this white room with like this robotic arm in the middle, right? And I was really puzzled. I said, I think, weren't you all doing sand testing equipment? Like, what the hell is this arm doing in the middle of this? It looks like something of the future, right? The way all guys have designed it, complete white with some I don't know. I think I should show a photo of it. So
Okay.
tell us exactly what this is.
Okay, so black box is a system inside a box. It's a, you can say, entire laboratory inside a box. So this laboratory inside a box has all the tests that a foundry would need, maybe for Greensand, for no bake, for CO2. And the system can acquire samples from variety of places in the foundry, bring it to the box,
Okay.
do all those tests like wet tensile test, friability, active clay test, dead clay test, n number of parameters, and then when you can relate it back to the casting traceability number, then all the different piece of puzzle fall in place.
Right.
Even you have the incoming result of bentonite interwoven into this. So then you get a big regression equation as to this result correlates with these parameters. So probably instead of this bentonite, I should be using this bentonite. Instead of this coal dust, we should use this coal dust. This should be the percentage, and the recipe is formed. So the black box helps you with recipe of how you want to do the casting as a final recipe.
Amazing. And you also mentioned that it's sand generic, like you can use it for green sand, for no-bake, for any sort of sand process.
Yes.
So how do you build in the correct type of testing equipment for all these different type of sands? Like I think it would be like a custom model.
Yes, it is very much custom. So our customers include everybody from bentonite manufacturers to foundries to resin manufacturers, you name it. And nobody really wants to do the laboratory work on their own. They would be happy to, just put some sample, select some tests, and get something done on its own, than doing the titration, seeing the result. If there's a blue halo coming in, nobody wants to do that anymore.
It's good I upgraded from a lab assistant.
The point is, there would be no lab assistant to begin with. So.
I would have a job 10 years later. Okay.
I think you would have a better job. You can just sit and analyze what is there, make the chemical changes, and
which was not being done, by the way.
Which is currently
I'm not sure it was being done. Okay. I think you mentioned this to me when we met. Talk a little bit about your experience with Indian Institute of Science.
Indian Institute of Science. So,
like, what was that chapter about? And I don't know, just tell me about it.
It's actually really very interesting. In COVID times, I tried making a ventilator, and we didn't have a pressure sensor. I made one without, which works on oxygen pressure and without electricity. It used to work very well, but Indian government wanted to have a pressure sensor, so I got in touch with Indian Institute of Science whether we can fabricate one. But then the professor there said that, why don't you come here? I will teach you how to fabricate. So that's where the PhD in ISC started, and I started working on cancer diagnostics. So, which essentially means to fabricate sensors to detect cancers. So sensor fabrication is something which is the heart of this entire gamut of detecting something. So that's also one of the objectives of the new startup that we have here called Sahas Labs. We would be fabricating sensors here. So we are also trying to raise an investment so that we can put up a silicon fabrication fab to make sensors here in Colaba itself.
So can we add like a form or a place where they could reach you in case anybody is interested to learn more about this? Right? I think we can include something below.
Sure.
Right?
Sure.
Or they can reach out to you directly.
Of course.
Fine. That's it. All right. I think we have pretty much covered with sand testing, small, medium, large foundries, a lot about sand testing and stuff. Let's just move to our bonus questions now, because I think this is really where the fun is. So Versatile has clearly come a long way. And I think your journey is just getting started from what I see today.
Yes.
So what is your vision for the next 5-10 years? Where do you see the company going?
So in next 5-10 years, one thing that I'm quite sure of is collaborations is essential. No person in the world can build a great thing on his own without a lot of collaborators. So in Sahas Lab, we have a bunch of people from ISC and Arjun, to be specific, so we can probably show his face later on sometime. We are looking forward to build integrated solutions into sensing, automation, And okay, say for example, let me give you a small one here. As a byproduct of what we are doing, we have created a small smelling device which can smell. So if you put it, in case of Foundry, if you put it near a mold, it will probably tell you how many VOCs are getting released from the mold. If you put it in a toilet, it will probably tell you whether the toilet is smelling good, bad,
Right.
or your scotch has, some amount of, how do you say, baser? Baser? What is it said in English? Baser, what is it in English? Like mixing scotch with something else.
Right.
Not an authentic scotch. Adulteration. So whether your scotch is
Okay.
adulterated or not.
Right.
These kinds of things would the device would sense. So that's one of the byproducts of where
Through smell.
Through smell.
Okay, only smell.
Only smell.
Right.
So you can swing around the sensor and it might tell you, oh, this is not Jack Daniels, it's probably Jack Daniels mixed with old malt.
Right.
We never know. So that's
Right,
something
right,
that it
right.
can tell you, or
Right.
the coffee brew it can identify. It can,
Right.
If you are running a large organization, it can tell you this area has higher VOCs. People should not be there. It's a safety concern and
Right.
stuff. So that's one of the things that has come out. We practically are working on a lot of things that would eliminate manual work
Right.
and let people have a better quality of life by that. So just like a laboratory in a box for Foundries, we are also working on laboratory in a box for pathology, which can simplify pathology in itself.
Right. I think it's a little off topic, but I just recently on another podcast heard there's a company, I don't know if they're in India, but in the US for sure, where they come into your home and they set up like these testing devices at various places to gauge the quality of air based on the smell that it's picking up. Like for example, maybe this paint is too carcinogenic. You would not pick that up, but you're smelling it. Right, so it has all these sensors, like maybe
True.
this table needs to be changed, the kitchen and various things, through paints, through chemicals, because we're using so many chemicals in our daily life, even
Very true.
fabric.
Very true.
So it has all these sensors around the house, and I think they monitor it over 30 days, 60 days to tell you what to change and replace, because this is something that 30, 40 years later will affect you, right? Not at the immediate, present. So I think this is something that you could also look at in a foundry, where you can identify the
Yes.
most lethal place to be at.
Absolutely.
Right.
That's definitely the thing. The sensor, that the smell sensor, you can use. You should be able to use it for those applications as well.
Right.
Also in the foundry for leakages, or foundry in itself is a very lethal place. Okay.
Right.
So there is no question about it. Being in a foundry is.
My words are the most lethal place.
But then I've seen a lot of people who have lived for 9500 years.
Yeah.
In spite of being a molder.
Actually, that's the
So-
thing with foundry men. The real passionate, hardcore foundry men, they're like living in their late 80s,
Yes.
mid 80s. They're writing books. They just refuse to give up.
Yes.
It's like a lifelong process.
So there's one gentleman called as A.R. Krishnamurthy, a real genuine genius guy,
Right.
who is a Greensand genius. I've been knowing him for quite some time now. So he's probably 90s, 100s, lives and worked with Greensand very, very closely. So that says it all. No? So
Correct.
he's been there, done that.
Correct.
Living long. So probably they build a resistance over the period of time.
Right. It's interesting. So today, sand is a natural resource. Versatile mainly thrives on sand testing. How do you see Versatile place for the future? Like, do you see this as a threat? Are you de-risking your company, whereas you're going into processes like loss form, which technically don't need a lot of sand? Is that like something that is on your mind?
See, though sand casting is considered to be a polluting process, if you ask me, and if the kind of people I have met all over the world, it's one of the greenest industry you would ever meet.
It's not only the polluting process of sand; it is the availability of sand, because you're having government shutting down mining facilities like there was in the south earlier.
True.
So that could be something where it's a natural resource and they declare like no more sand mining. That could affect us really, really badly.
Actually, the effective recycling is the right solution for this problem.
Correct.
It's an age-old process which recycles metal, which should persist in the future, and it will with the right recycling methods. And if there are alternative methods coming in like laser sintering, then and things like that. Because see, any change that will happen is not going to happen suddenly.
Yeah, it's over a period of many years.
Over
right?
the period of a few years, it would happen, and it actually starts with design. So somebody trying to design an automotive, a car or a tractor, if the designer by design puts a laser sintered and cured part into the design instead of few castings, then those parts go out of the basket for a iron casting foundry or a steel foundry. So the changes start with the designers adopting the processes. So the way things are going further, the 3D printing, though it's not a very efficient process at this point of time, at some point of time it would be. The laser
Right.
costs would come down.
Correct.
The amount of productivity might not be there for a few years, but ultimately the designers themselves would opt for designs which are intricate, would replace multiple components at the same time, and essentially try to justify laser sintering as a process. Laser sintering is just one example. There can be many other
Correct.
examples as well.
Correct.
So the threat is not only on the natural resources front, but is also on the engineering front of it.
Yeah, whether castings will sustain or not.
By design. So that's another frontier where foundries need to look
The
at.
fact that you are actually aware of all these processes means that you are already de-risked, looking at de-risk as an option. But I think since the timeline is so far away, I don't think it's an immediate threat for you at this point.
We consider ourselves as equipment manufacturers, instrumentation, and AI/ML with Sahas Labs and all these things. So we actually don't need to de-risk. It is one segment which is going to live for certain duration of time,
Correct,
say for
correct.
another 30, 40 years.
Right.
Meanwhile, something else, probably pathology will progress further, probably the smelling, air quality, betterment of air quality, these kinds of things will go further. So as an instrument manufacturer, we are there with a
Right.
bunch of products.
You're already
that
pretty
there
well
are.
covered.
So
Right.
that's where we are at. So,
Right. So you've been to a lot of foundries globally,
yes.
right? And you extensively travel because over the last couple of weeks I've been trying to get a hold of him, and he is doing a lot of travel. So what country is that? Like end of lunchtime?
End of lunchtime.
All right, we've been talking a long while. So what country where you went into a foundry in that country and you had an expectation of X, like just superseded your expectation and you had an expectation of Y. So what was that country, and narrate that experience for me.
See, I would say that India has exceptionally good foundries. The quality systems that Indian foundries work with are exceptional. Uh, but the problem that I've already stated with earlier, that we have not so great raw materials. But the foundries abroad, what I have seen, don't have the kind of quality systems that we have here. But they are performing much better on the outputs as well. So if you ask me which foundries are the best, probably I would say Breaks India. They go to the bottom of an issue. If they want to buy bentonite, they would go to a bentonite mine, evaluate their process. They're a process-oriented company,
Right.
which do a really, really good job at monitoring and establishing processes. Some Japanese foundries, they would have a compact sand plants. They would maintain their foundries well. They'd make sure that there are no pilferages of sand, but maybe not. The output, not really sure. So it's a mix of a variety of different foundries that I would call good, but on different rating scales, not an absolute sense.
Right. So after traveling to some of these foundries, what is the latest technology you've seen that's coming into the industry?
We have already talked about it. So that's what it is. That's what it's getting to. Most first world countries that I've traveled to, almost every large foundry, because smaller foundries are almost obsolete in the Western world. Larger foundries has inquired and would want to have a black box and a VCAD and a control feedback loop and traceability.
Correct. I think the traceability is the underlying reason that buying all this equipment.
So, more or less, if you talk about the current state of affairs, people are trying to digitize their operations through Industry 4.0. Still, 5.0 is a little far away, but people are trying to digitize their data just to understand their own processes.
Right.
That's where the industry is at right now. So,
Right.
it's a transition period. People still don't know what they will find out of it. There have been a few case studies of people benefiting something from IoT 4.0, Industry 4.0, but they are not yet conclusive. So transition period, we will see the results in a couple of years.
Right.
Till then, we cannot really say that okay, this has worked.
I was at Anand's factory yesterday in Belgaum. I don't know if this episode will come after or before that, but I saw some of the really cool stuff that he's doing. Like for example, he's tracking every single thing on different dashboards. Now the issue is that every single dashboard is provided by a different company. I mean, using IoT for a different part of the process. So there's no one sort of software or UI which you can see everything's integrated. So he still has to look on his phone for this app, look on the computer for this, but the amount of data that he has, and he's set up like these markers. Anything there's a small variation and it goes over the threshold limit, immediately it signals out. It's color coded, and he can almost pinpoint like, okay, this is the problem. He can predict where the issue is going to arise in the future, like even from maintenance related. So the amount of IoT technology that we have in our foundry industry today is really amazing.
Yes.
Already.
Yes, you're right. And in a seminar in Ahmedabad about 7-8 years ago, I had recommended people that you should start employing computer science people and data scientists,
Right.
Rather than a few other people that you would rather
Right.
have, because integrating these platforms together and having a consolidated view and analysis which is done centrally at one place,
Correct,
is the key thing, and it requires a lot of attention to detail. So even deploying an ERP system is a pain.
correct.
Now we are talking about real-time operations getting integrated together.
The implementation is the hard part, especially. Right.
So
right.
it's even a bigger pain,
Right.
because there are data synchronization issues. Now this is more time-based than an event-based. So time domain things and synchronization are definitely a big thing. So if Anand has like a couple of computer engineer guys or IT guys, data scientists, sitting and integrating these apps together somehow, would probably make a lot more sense for him going forward in a couple of.
Correct. Right. So I think lastly, we discussed a little bit about 2 generations being skipped, right? I think that's what you mentioned. So what do you think the solution is? I mean, of course, this is a very large macro problem, but how do you see this playing out in 10, 20 years? Where do you see a solution to it?
So skipping 2-3 generations is the problem that we talked about. I think let me elaborate that a little bit.
Right.
So this started somewhere close to 1990s and 2000s when entire generations went into software engineering and IT. So core jobs people took up in many cases because of force, because they could not get into something else. And
Right.
some people also went into core jobs because of choice, but very few people. And there has been a loss of core domain knowledge into core industry like mechanical,
Correct.
metallurgy. Plastics was non-existent then; it is still hardly existent today in India. But this domain knowledge is on the verge of losing it. People who know about people who know about designing robust processes are on the verge of retirement.
And there's no documentation.
There is no documentation.
Right.
And even if there is documentation, you always need a good master to teach you. And if that master is way above the rungs in a corporate ladder and is not going to teach you when you are an engineer, so it's exactly like, say, in COVID times, a lot of institutions, colleges lost their culture. So 3 years of nobody being there, many masters colleges
Correct.
lost their festivals that they would do otherwise, because there was no link between the seniors and the juniors. That processes were lost. So just like that is where we are at this point of time. So there are very few solutions to it. One is a capital intensive solution that you just get rid of the problem that there is. You don't have manpower, don't use manpower.
That's one side of it.
That is one side to it. That's how mistake proofing happens. Mistake proofing as a methodology, first thing that you see if you can eliminate the process.
Correct.
The second part is if you cannot eliminate the process, then the other options pop into like upskilling. Then upskilling as in you get somebody who doesn't know anything and teach him over a period of 6 months time and make him capable.
Correct.
So upskilling is another solution. There are very few solutions to it, and that's where we are at. It's a problem which has been created over 30 years. It's not going to be solved over a couple of days for sure.
So anyway, thank you so much, Pushkraj.
Yes.
Thank
Thanks
you for
a lot,
being
yeah.
here. It was a really, really amazing conversation, and I never expected to have like this level of like industry outlook covered on this podcast. So it's really amazing. Thank you for sharing your insights, and thank you for being on the show. Thank you.
Thank you, Ian.
Thank you.
Thanks for your time. Good day.
Is there anything else you'd like to add?
Nothing else. I think there is a lot to talk about, and there's so many more different topics.
Yeah, we'll put the link to his LinkedIn below, who's being managed by his family now, and they were debating what they should use as his profile picture, right? So if this comes out in time, his LinkedIn will be below, his number as well, so you can reach out to him for the investment opportunity as well as anything else that you like to pick his brain on. And I think he has a lot more to talk about than in that head of his. So thank you so much for sharing.
Thank you. Thank you once again. Yeah.
Thank you.
Good day.